Working alone, A can complete a task in A days and B can complete in B days. They take turns in doing the task, with each working 2 days at a time. If A starts, they finish the task in exactly 10 days. If B starts, they take half a day more. How long does it take to complete the task if they both work together? Now let's avoid using their A and B days because that will introduce a lot of fractions into the problem. Instead, what I'm going to say is I'm going to assume that, or I want to say that A does X amount of work in a day. So let's write that down. Let's say A does X amount of work in a day, and B does Y amount of work in one day. Now notice, if A starts and they finish in 10 days, and A will work for 2 days, then B works for other 2 days, then A works for 2 more days, B works for 2 more days, and then A works for 2 more days, and the job is finished. So that means in the first situation, A will work for 6 days. So 6 times the amount that is done in a day, plus now B works for 4 days. So this is the total amount of work. This is the total amount of work. Now notice, if B starts, they take half a day more, which means now B is going to work for 6 days, but A is going to work for 4.5 days. Why? Because B starts for 2 days, then A works for 2 more days, then B works for 2 days, then A works for 2 days, and then B works for 2 days, and then it has to come to A, who finishes the work in half a day additional, which means this time B is working for 6 days, so this is going to be 6y, and A is working for 4.5 days. So the total amount of work is either this or that. Now we can actually solve, we can get a relationship between x and y. So let's simplify this equation. So if you subtract 1, or if you move this x over here, then you get 1.5x. And you move the 4y over to the other side, you get 6y minus 4y, which is 2y. And let's just simplify, change this, double both sides, that way we don't have any decimals. So we get 3x is equal to 4y. Or in other words, x, which is the amount of work done by A, is actually 4/3 the amount done by B. So this will be a useful relation. Now what's happening is, how long does it take to complete the task if they both work together? Now when they both work together, what happens? In one day, how much of work are they going to accomplish? So in one day, they are going to work x plus y, because A is going to work x and B is going to work y. But x is what? 4/3 of y. So in a day, they are going to finish 4/3 y plus y. 4/3 y plus y, which is 7/3 y of the work. 7/3 y. Now, there is a fraction, so we don't like that. So what we do is, if in one day it's 7/3 y, in 3 days they will finish 7y part of the work, or 7y amount of work. Now the total amount of work is how much though? So let's find out. Total amount of work. How much work is needed to complete? Notice the total amount of work is this expression, or this, but let's use this one. It is 6x plus 4y. That's the total amount of work. And notice 6x is actually double of 3x, which means it's going to be double of 4y. So that's going to be 8y plus 4y. I'm trying to get everything in terms of y. So the total amount of work is 12y. So notice, when they work together in 3 days, they finish 7y. So let me write down a proportional relationship. 3 days would correspond to 7y amount of work. And what I need to find out is, what does 12y correspond to? And I can cross multiply. I multiply this 12 times 3 and then divide by this 7. So that would be 12 times 3 is 36. So it's 36 over 7.